Hi, my name's Dylan. This is my FE problem presentation. Through an example problem, we will cover cash flow diagrams, present value calculations, and net present values. Before that, we need to cover the basics of present value problems. More specifically, we're going to be focusing on the approach of present value problems. It's important to note that the terminology that's going to be used in this video is my own terminology. So other instructors and individuals may use different terminology, but the method of approaching these problems will generally be the same. That being said, the most basic present value term is the single payment present value, which is illustrated in the following equation. PV equals FV divided by 1 plus R to the power n, where PV is the present value, FV is the future value, n is the number of payments for a given period of time, and R represents the discount rate. This describes the present value of a single payment any time into the future. The next equation we will discuss is the uniform series present value, which is presented in the following equation. This equation is used for constant payments over multiple periods of time. So, let's say I were being paid $5 for 5 years. That's a uniform series of present value. It's just a more efficient way of doing multiple present value calculations that are more repetitive and constant. It's important to note that the variables used in this equation are going to be the same as those used in the single payment present value equation. The final equation we will discuss is the net present value formula. This is a rough formula I threw together to describe the net present value of a typical investment, as that's going to be the case in this problem. We will use the formula NPV equals the sum of the present values minus the initial investment cost. Now that we've covered the basics, we can approach the sample problem. A contractor wants to buy a piece of equipment to use over a 10-year period and then sell it. The equipment costs $25,000 and can generate $8,000 a year. At the end of this 10-year period, the contractor sells the equipment for $3,000. Using a discount rate of 3%, how much money will be made or lost? So from the problem statement, we have been given a couple of important terms. The initial cost will be $25,000. There will be two future values, which I will call future values 1 and 2, respectively, a time period of 10 years, and a discount rate of 3%. The first future value is going to be the $8,000, which are going to be paid over a constant period of time. A second future value, however, is going to be $11,000, which will be the cumulative sum of the final return on investment in addition to the $3,000 selling price. Given the future values and initial payment, we may develop a cash flow diagram illustrating the cash flow over the course of the investment. Note that the initial investment, the subsequent $8,000 payments over the next 9 years, and the final $11,000 payments in the final year are the key values presented by this cash flow diagram. Using the diagram, we can analyze the problem with respect to the present value formulas we discussed. We will begin with the single payment present value, which is simply the final $11,000 payment. To calculate this present value, we will use the single payment formula as follows. PV equals $11,000 over 1 plus 3% to the 10th power. This is because it's the 10th payment only. And that's going to equal roughly $8,000. Similarly, we can efficiently calculate the present value of the $8,000 investments over the initial 9-year period by using the following formula. 8,000 times 1 plus 3% to the 9th power minus 1 divided by 3% times 1 plus 3% to the 9th is equal to the present value of roughly $62,000. The final step is to determine the net present value by accounting for the initial investment with respect to the total present value. In other words, the net present value will simply be the total present value we calculated in the first two steps of the problem, minus the initial $25,000 investment. When all is said and done, the net present value will come out to be $45,474. And that's all there is to it. Thanks for watching.